So the easy way to understand limits is to be f, our function here. F of x is equal to 1 over x. And we can know division by 0 is impossible. So that's why we write x cannot be equal to 0. So if we plug in like this 1 over the 0, it is impossible. So we just remove that from our mind. So there's a nice way to tackle our problem is to use the idea of limits. So limits is to use some numbers which are really close to a desired number which we cannot calculate it. So for example, in our 0 we have the 0 and we cannot calculate 1 over 0. But we can plug in some really close numbers close to 0 and we get some result. And I'm gonna try to draw this plane here, and we have 0, and we know we have a negative side here, and we have a positive side here, and so we can notice we have two numbers that can be close to 0, two numbers located just right here. Let's take a number like 0.001, and also here let's take 0.001, and I mean minus here, sorry, and let's plug them in our function. So for example here, f of 0.001 is 1000, and if we take f of minus 0.001, we take minus 1000. And if we take really small numbers, I mean some small, like for example 0.0000, I don't know how much of 0.1, we get also a really big number. So for 100 and a really big number, and same for this one. If we take minus 0.0000 thing, we get minus 100 thing, a really small number in the negative side, because we say small numbers. As you can see, if we take some numbers really close to 0, we get a big number, a really big number on the positive side, and a really small number on the negative side. And if we draw the graph of our function, we can understand more. So I'm going to draw the graph very quick. So for example, just like this one. So the graph looks like this. We can notice here at 0 there's no value, but when we take some numbers close to 0, in the positive side we get a big number here, and if we get closer to 0 we get a really big number, maybe here. I'm drawing approximately. We say qualitatively, I think so. And if we take a really close to 0 here, a number close to 0 here on the negative side, we get a really small number here, a really small number here. And when we take, like, the more we get close to 0, the bigger number we get on the positive side, or the smaller number we get on the negative side. And since we know that numbers are infinite, we adopted the idea of infinity, that if we take some numbers close to 0 here, we get plus infinity, and if we take some numbers close to 0 here on the negative, we get minus infinity. And to write this, we have a notation. And we write like this. So limit f of x when x is approaching 0 because we're getting close to 0. It's not 0 when approaching 0. And if we write the greater side, the greater sign here, it means we are on the positive side, or numbers which are on the right of 0. We get plus infinity. And if we write like this, limit f of x when x is approaching 0 on the negative side, so it's on the left side, we get minus infinity. So this is the idea of limit. And we can do the same thing, if you can notice, on this side and on this side. I won't explain much. You can experiment this on your notebook. If we take really big numbers for x, we get small numbers on the positive side, and if we take really small numbers here, we get some numbers close to 0 on the negative side. If you can experiment it on your notebook, and you can see the difference. I'm just gonna write it here, just to be things formal. So limit f of x when x is infinity, is approaching infinity, we get 0, and limit f of x when x is approaching minus infinity is also 0. We can just go to our graph again, and as you can see, if we take some numbers which are on the infinite side of the positive values, like this, we get a really small numbers close to 0. And if we take infinite number, like some kind of a really small number on the negative side, so this is positive. So if we take some really small numbers here on the positive side, we get a number which is really close to 0 here. So you can experiment it on your notebook, as I said before. So I hope you understood, and thanks for watching.